All right, so we're gonna move on to the next section. It's 9.6. And we're talking about factoring trinomials with a leading coefficient of not 1. So prior to today, we've talked about multiple different types of factoring, right? We've talked about difference of two squares. We've talked about perfect square trinomials. We've talked about factor by grouping. And we talked about regular factoring, where you take the last term, you take the constant, you find the factors that multiply up to this number but add up to the middle number. But the one thing about those trinomials is that the number in front of our squared term was always 1. So this is your leading coefficient. This number out in front here, that's your leading coefficient. So this is your leading term. Your leading coefficient is that number right there. And that number has always been 1 up until this point, unless it was a perfect square trinomial. So today we're going to talk about how to factor polynomials where this leading coefficient is not 1 and it's not a perfect square. It's not a perfect square trinomial, okay? Meaning this term right here is not a perfect square and this term here is not a perfect square. So how are we going to factor this when we're looking for factors of this number that add up to this number, but there's no such thing because the factors of 7 are 1 and 7, and there's no way of getting that to add up to 23, right? So we have to take into account that there's this 6 out in front of our x squared. Now, there is a guess and check method that you can use. So by now, I know you probably have gotten into the routine and gotten used to the fact that our answer is always consisting of 2 sets of parentheses. And we break up this term and we break up that term, right? And we end up with 2 factors of 7. So we're going to, let's just say 1 and 7, because that's the only combination we can have, because 7 is a prime number. And then we have to break up 6 somehow, and we have to break up 6 into 2 different terms. And we know it's going to be x and x because of the x squared. And we know it's going to be plus and plus because it's positive and positive. But how do we break up that 6 is the question. And there's different combinations of 6 that we can make. We can do 1 and 6, we can do 2 and 3, or we can do 3 and 2. And in this case, the 3 and 2 makes a difference. And here's why. Let's say we put the 3 here and the 2 here. I'm just randomly putting them in. The only way to check to see if this is right is to then go through and FOIL this out to see if you're going to get this trinomial back. So if you do first, outside, inside, last, you will see that this is the correct answer. And then I just randomly guessed to see if it would work. Okay, but there is another process, and I don't recommend the guess and check method until you've really gotten familiar with the process of factoring. So let's go through this process of factoring when you have a leading coefficient that is not equal to 1. So what we're going to do is we're going to take this leading coefficient, which is 6. Okay, I'm going to go ahead and circle it. And we're going to multiply it by the last constant, right? It's going to kind of look like earmuffs like this. And I circle them both just to help visualize the process of what we're doing here. And we're going to multiply these 2 numbers. So 6 times 7 gives us 42. All right. So now we want to take 42, list out the different factors of 42 that are going to multiply to be 42, but add up to 23. So we've got 1 and 42. Okay. And I'm going to jump down to 2 and 21. Right. And I know right away that 2 and 21 automatically is going to give me 23. So I'm going to stop listing. Okay. So now what happens? Where's my pen? There we go. I'm going to keep my 6x squared, okay? Instead of writing 23x here in the middle, I'm going to do this in a different color. Instead of writing 23x, I'm going to write it as 2x and 21x. So 2x plus 21x, because 2x plus 21x gives us 23x, okay? So plus 2x plus 21x. And then I'm keeping the plus 7. Okay? From here, what we're going to do is we're going to complete the factor by grouping method. So now I'm going to go through, put parentheses here. I'm going to pick out a GCF between the first 2 terms and pick out a GCF between the second 2 terms. okay? It doesn't matter what order you put the 2x and the 21x in. It will work out either way. So I'm going to go through and pick out my GCF. My GCF is going to be 2x for the first two parentheses. I'm going to be left with 3x plus 1. And then my GCF for the second two set of parentheses is going to be 7. So I write plus 7, and I'm left with 3x plus 1. Okay, again, parentheses are the same. So I'm going to go ahead and factor that out. And then I'm left with my 2x plus 7. And that's the entire process. Okay. Now, if you notice, that's the exact same thing I got from my guess and check method. But guess and check can be a little more complicated. It can be a little more confusing as well. If you're not very familiar with the factoring method, I highly recommend sticking to this idea until you become more comfortable with it and you really see that breakdown of the first term and the last term with the factors. Okay, so let's do it again. Here we go. So again, first step is to take the leading coefficient and multiply it by a constant. So that's that last number back there. So you're going to get 2 times 2, which is 4. Right? And our factors of 4, which is 1 and 4, and 2 and 2. Now, we need positive 2, or positive 4 in this case, negative 5. So that's going to give me negative 1 and negative 4. So I'm going to keep my 2y squared. My negative 5y becomes negative 1y minus 4y. And then I still have my plus 2. Okay? So all I'm doing is rewriting this negative 5y as negative 1y minus 4y. And it's the same thing. It's equivalent. Now I'm going to go through, do my factor by grouping method. Right? Find the GCF, which is going to be y. So I get 2y minus 1. Find my GCF, which is going to be negative 2. So I get 2y minus 1. Again, parentheses need to be the same. So you get 2y minus 1 and y minus 2. Okay? Let's walk through one more, and then I want you to try the rest on your own, and then come back and check your work with mine. So, here we go. 7 and negative 8 gives us 56. Draw your arrow. We got 56. So let's go through our factors of 56. We got 1 and 56, 2 and 28. I'm going to glance at my middle term. My middle term is going to be negative 26, and I know I can get that with my 2 and 28, so I'm going to go ahead and stop. My 7x squared is going to stay the same. Break up my negative 26x into negative 28x. Plus 2x, and then keep my minus 8. Okay? Factor by grouping, so group them with parentheses. Factor out your GCF, so 7x, which gives me, x minus 4. GCF is 2, so I get x minus 4. My parentheses are the same, so we get x minus 4 times 7x minus 2. And you're done. Okay? So pause the video. I want you to try D, E, and F on your own, and then come back and see if you did it correctly, or keep watching if you need one more example. Okay? All right, so here we go. Multiply your 5 and your negative 3, you're going to get 15, right? Technically negative 15, but right now I'm not worried about the negative. 1 and 15, 3 and 5. I know right away looking at my negative 14 that my combo is going to be my 1 and 15, but I keep my 5 d squared. I'm breaking up this negative 14d into negative 15d plus 1d, or just d, minus 3. Factor by grouping. Again, guys, doesn't matter if you switched up your 15d and your plus 1d, you should get the same result in the end. Okay? So find GCF, you get 5. D factored out, you get d minus 3. GCF is 1, so you're going to factor out a 1, divide by 1, which means you're still left with d minus 3. Parentheses have to be the same. D minus 3. 5d plus 1. And you're done. Okay? Again, so hopefully by now, you pause the video, try these on your own, and you'll just be checking your work with mine. So we're going to go a little bit quicker. We got 2 and 10. Gives us 20. 1 and 20. 2 and 10. 2 and 10 is going to give me that 12 that I need. So I have 2v squared. I got my negative 12, and I'm going to get that with my 2 and 10. So minus 2v minus 10v plus 10. Factor by grouping. 2v, v minus 1. Take out negative 10, then you get v minus 1. And there you go, okay? As we go into the last problem here, actually, you know what? I'm going to hold off on that. I'm going to go through the last problem, and then I'll kind of come back to that. So here we go. Same thing. 4, 6, you get 24. So our factors are 24. I kind of wrote it too close here. We've got 1 and 24. Whoops. We've got 2 and 12. 4 and 6, 3 and 8. I skipped 1 in there. Which combination is going to give us the 14? It's going to be the 2 and the 12. So I'm going to keep my 4y squared. We're breaking up the 14y into plus 12y, or plus 2y, either one, plus 2y. Plus 6. Factor by grouping with your parentheses. Factor out GCF. 4y. Whoops. Going to give you y plus 3. GCF of 2. Again, y plus 3. So we're going to get y plus 3 and 4y plus 2. Okay. Looking back, what is one step that I did not discuss that is always the first step that we complete in every single time we factor? We always want to look for what before we proceed. We always want to look for that GCF. And looking at this last problem, even this problem right here, both of these polynomials have a greatest common factor of 2 among every single term. And I'm noticing that as we get down to the bottom because I still have a GCF that's left here. So technically, these are not factored as much as we possibly can. I can still take out a GCF between these two terms. So I can leave my v minus 1, but I have a greatest common factor of 2, and it should be v minus 5. We never write a greatest common factor like that in the middle. We always put it out front as a coefficient. So it should be 2 times v minus 1 times v minus 5 is what your final answer should be. But today I really wanted to just focus on the process and completing the same process over and over again. Okay, so again, same thing. They both have a GCF of 2, right? So the only difference here would be that I would have factored it out in the beginning, and this factor by grouping would have been a little bit different. And again, you would have gotten this as your result instead, which then we put the 2 out in front. Okay, so from now on and when we practice, I want you to look for that GCF in the polynomial before you go through and factor. But today I just really wanted to focus on, and I really want you to focus on learning this new method and learning this process. Okay, just always keep an eye out for that GCF because it will pop up in there. Okay.